Astropoulos, and I'm a PhD student in Columbia University. And today I want to talk about our experience in phenotyping, the lessons we learned, what our plans are, and actually how wonderful this whole experience was. So if you go to the next slide. So we had 27 people in our team, and we were able not to fight, and we were able to manage the time differences, which is, I think, is pretty amazing on its own. And we had people from different backgrounds. We had people with the vocabulary expertise. We had people with the clinical expertise. We had people with the epidemiology and data expertise. And we think that this is one of the key things that allowed us to successfully manage those phenotyping processes. So the first step was to do the literature review and explore what's been known on the topics and what the best practices were. And then we used this knowledge to build phenotypes for all of the studies, for the estimation studies, for prediction studies, and for the characterization studies. So we started from the small blocks and small concept sets. And here, one of the highlights is that we used Atlas and we were able to actually explore the records across the whole Odyssey network, which provided us the frequency of concepts across many data sets. And it was really useful because you can just see what's in the data and what concepts you can use. And based on that, you can create the comprehensive concept sets. So after we created those concept sets, we went on to evaluate our small blocks, and we used the new packages that also helped us a lot, and I will talk about that later, which is the cohort diagnostics and the Phevaluator. And finally, after we validated those, you can actually switch. After we validated those concept sets, we used these blocks to create the final phenotypes that will be used in the studies. So if you go to the next slide, I actually want to share the 3 key lessons that we learned in this process. So the very first one, which was something new to us, is that many phenotypes actually shared those small blocks, and we were able to reuse the small concept sets into many different phenotypes. And then you can ask yourself, okay, so you created a concept set, you created the small piece, but how do you make sure that it's a good piece, and how do you make sure that you can reuse it across different phenotypes? So the next lesson that we learned is that those phenotypes and those small blocks are driven by their intended use. So you can think about that in the following way. How do we find a condition, or how do we find people with a certain condition, for example, with the influenza? So we can use the very narrow specific algorithm using the clinical features, like, for example, a diagnostic code of influenza or a test result, or we can use a broad definition, which will also allow us to capture other people that were coded, for example, with the symptoms, because we know that many patients with influenza do not get this diagnosis and do not get tested. So when you think about that, you can imagine that we want to split those 2 definitions based on how we intend to use those definitions. And if you want to capture a lot of patients, then you want to use the broad definition. If you want to be specific, you will use the narrow definition. And there's the trade-off between the specificity and sensitivity, with no right single answer, but rather was defining how you intend to use that. And the third lesson, that may be the most important one, is that any phenotype requires knowledge of the data. So we are used to rule-based phenotypes, where we actually use those clinical knowledge and we define rules and we create complicated logic behind those phenotypes. But if we don't know the data, if we haven't explored the data, our phenotypes will not be good. And on the next slide, I will show you how it worked in our processes. So the very first thing is we created the concept set and the phenotype for sepsis. So the logical way you can do that is you can select everybody who had a sepsis diagnosis or a sepsis-related diagnosis. And this is what we do, and this is what people in the literature have been doing. But then when we run the cohort diagnostic, we actually found that we are missing an essential code. For example, the systemic inflammatory response syndrome, which have to be in this definition, but we weren't aware of that because we didn't explore the data. So exploring those concepts that we should include in our concept sets to make them comprehensive is the first use of the cohort diagnostic and the first thing you have to pay attention when designing a phenotype. And the second application of this lesson is to explore other features of the data. So even if you designed your concept sets and phenotypes perfectly fine, keeping in mind all the possible variances scenarios, creating the comprehensive concept sets, you still may be missing something due to the coding variances or other artifacts of the data. So here what you can see is that we developed a concept set from Malaysia, and when we ran the cohort diagnostic, we found something suspicious. So in 2015, we found a drop in the incidence rate of the patients with this code. So we started questioning ourselves, like, why is it happening? And we figured out that because of the switch from the ICD-9 to ICD-10, those patients were coded using a different concept code. So then we adjusted our phenotype to include either malaise or malaise and fatigue. And you can see that after we run it for the second time, we saw a natural curve with no suspicious fluctuations in that. So the second lesson in exploring the data is that sometimes the data has its own features, coding practices, other biases that you may want to capture, and you have to actually go into the data and explore that. And for that, we have the concept cohort diagnostics, and we have the p-evaluator to see whether your phenotypes were specific or sensitive and how they performed. And if you go to the next slide, I think it's pretty amazing that we did the literature reviews for 36 phenotypes in a systematic manner. So we actually went to the PubMed, we created the search queries, we went through the whole literature, and this is something that can actually inform the further studies. Based on that, and based on what I discussed before, we created more than 300 cohorts. And out of those, we validated, so we went through all the processes, all the steps, and we validated more than 100 cohorts for the prediction, estimation, and characterization studies. And we also published the results of the evaluation on the data.odyssey.org, so you can go and explore it and see how it looks like and how the data look like. And I also want to mention that some of the phenotypes were really complex. So the snapshot that you have over here is just a small portion of one of the phenotypes, and the actual phenotype was 3-page long. So I got tired when I got to the bottom of the page. And with that, of course, it's not the end. So we have a lot of things to do. And our next steps will be actually completing the remaining cohorts, because we have many more ideas and many more concepts that we want to create and we want to explore. We have to finalize the cohort evaluation package for all of the cohorts and publish that, so that everybody can actually go and see on the and see the cohorts and see how they perform on a different concept, on the different data sets, including the EHR data and claims data and international data sets. And finally, we think that it will be useful to write a paper about our experience, because based on my knowledge and my experience, this is something that has never been done before. And those lessons that we got have never been reflected in the literature. So I think that people from different research fields can actually learn from us and use it as the best practices for the phenotyping.